Okay, let's continue on here reviewing what we did in class. So I have these parameters in the constructor that I use to set the instance variables. One thing you might have noticed, which is a bit peculiar, is that I used a different name for the variables in the parameters than the corresponding name of the instance variable that I wanted to set with it. The reason is, if I tried to use the same name, there's some ambiguity there. So, now I have the same name for the parameter as I do for the instance variable. And I have kind of a nonsense looking statement like name equals name, age equals age, height equals height. If you ever see like x equals x in code, there should probably be some alarm bells going off in your head. That doesn't seem quite right. But let's see what happens when we try to do that. So what's it actually going to print out here when I do it that way? So let me recompile this thing. Right? And I get some pretty weird answers, okay? And all I did was I changed the name of the parameters and updated the name here. So what's happening is we have to be very careful. When we say name equals name here, name actually refers to the parameter, not to the instance variable. The parameter kind of gets priority here in what it interprets. And so I'm saying, okay, the parameter equals itself. Well, that's not quite right. That's not going to do anything, right? It's certainly, if I say the parameter equals itself, it's not going to update the instance variable. And so the instance variables are going to have just random names or just random values based on what happened to be in memory. So every time I run this, I'm going to get something a little bit different. The only thing that does remain the same is the 100 because I explicitly updated that later. But yeah, I'm getting some pretty weird numbers here. Very, very tiny, actually. We're really short. So this is times 10 to the negative 310. Okay. So that's not quite what we want to do. But it's also annoying to have to use a different name for what we ultimately want the parameters to be set to. But there is a solution. But to explain the solution, I have to explain object pointers or object references. And so look, an object or a class, just like any primitive type, has another type which is a pointer to that class or a pointer to an object of that class. So if I were to say, for example, person star pointer is equal to the address of the Chris object, then all the normal pointer stuff applies, right? So if I were to just print that out, I would get a hexadecimal memory address. So this is, just some big number, which is the address of the object Chris in memory. Then of course I could dereference the pointer, and then I could actually access the variables. So I'm doing this parentheses here, so it's saying I want you to dereference this pointer first. I want you to follow the arrow and pull out what's in memory at the address that this points to, which is Chris, because that's how I set it up. So it's basically like plugging Chris in here. Now I can say something like, well, okay, Chris.age is equal to 33. So if I do that, now I see, okay, cool, that worked. Chris is 33 years old. Okay, so that's object references there. It works, again, just like any other pointer. This is a different type from the class person. This is a pointer type to class person. Okay, but everything is exactly the same. The object Chris resides somewhere in memory. It's definitely going to take up more space than your average primitive type because it actually has multiple primitive types in it. But anyhow, we can dereference it, and then we can do the dot notation like we did before. All right? Now, it turns out every object has an instance variable called this, which is a reference to that object. So if I were to say down here, when I go to print info, let's just look at it. If I said cout this equals this. Okay, let's just check this real quick. So I want to go print the info of Chris. Right after that, let me print out the address of Chris. And so let me recompile and run this. And so we see that the address of Chris is, oops, let's see. Yeah, okay. So the address of Chris is this hexadecimal number, which ends in 70. And we can see that this is equal to that exact same thing, okay? So just to demonstrate to you, the address of the object is this, okay? So what we can do is we can actually access any of the instance variables by dereferencing this, okay? So if I want to disambiguate between the parameter name and the instance variable name, what I can do is say, hey, you know what? I actually meant that on the left side of the equal sign, I wanted the name that belonged to this object, okay? So what I'm going to do is I'm going to dereference this, which again, it's a pointer to this object that we're currently calling this constructor on. Now I can say dot. Okay, so I'm going to dereference this object. So I'm going to go to the address, the memory address of this object. I'm going to pull out the object. And now I can use the dot notation to access the instance variables of this object. Okay? And so that should actually now allow me to disambiguate between the parameters to the method and the instance variables. And again, just like any other instance variable, this has a different value between different instances of objects. So in particular, it has a different value for the Chris object than it does for the Nick object. So you see that this value is different for the Nick object. Actually, you see it's about 20 bytes ahead in memory for the Nick object. So this gives me an idea that if these objects are adjacent in memory, then they probably each take up 20 bytes, roughly. Actually, does that make sense? Because the const char, this is a pointer, that would be 8 bytes, int would be 4 bytes, and then this would be another 8 bytes. 8 plus 8 plus 4 is 20, so yeah, that checks out. Okay, just a quick review of how things are laid out in memory. Okay, but anyway, let me show you that this actually works now, and it actually properly initializes these variables in the constructor. So now we're in good shape. This is all making a lot more sense. Let me get rid of this now. Okay, so again, this is a pointer to the address of the current object that is calling whatever instance method. And so it's not a bad idea to get into the habit of using this when you access things. Actually, the notation I have here is a bit cumbersome. Let me jump down and mess around with this pointer and show you. You can do this. This is fine. You can certainly use that notation where I say, okay, explicitly what I'm doing is I'm dereferencing this pointer, and then I'm pulling out a variable and I'm setting the variable. And the same thing for the method. You know, I could say, if I go back and look, I have this other method called getAge, and I could definitely also dereference the address and call a method as well. Right? That would work. That sort of thing. But this is a bit cumbersome. So there is a shortcut in C++ that does the exact same thing. So the arrow notation is equivalent to whatever, so I guess I'll say, you know, foo arrow is equivalent to dereferencing foo and then the dot. But notice how this imposes 4 additional characters on me. I have the left parenthesis, the right parenthesis, the dereference, and the dot. Whereas the arrow is only 2 characters, and it just looks nicer, right? And so what I can do, maybe I'll leave one of these around just to remind you what's actually going on, but it's more common to write something like this. And that looks a heck of a lot better. So let's just compile, make sure it does the same thing. Okay. But this is great. Now that we have object references and we have a nice syntactic way to dereference them and access. So this does 2 things. It dereferences and accesses an instance variable or an instance method. So now we have a good way to pass around objects by reference. And so I'll have you do a little exercise on this. We can pass a pointer to an object, to another method, and then we can change the object in that method, but then the changes will persist beyond the lifetime of the method that was called and pass the pointer. Okay, so now we can play all the same tricks that we did when we learned pointers before and pass things by reference. Okay, so let's do a quick exercise on that. And then I will proceed on to one more thing I want to talk about.